We're now successfully generating a modest amount of solar electricity from our off-the-grid shipping container house. We have full-time mains electricity and we run a fridge freezer with no difficulties. This video is going to show how I wired up my solar panels through a charge controller and an inverter to make two 40 volts mains. I'm going to include a lot more technical detail because I made quite a few mistakes along the way, and I hope you can learn from my mistakes. The wiring is actually quite simple. I've bought an external house electrical utility box and I mounted it to the outside of the container. It comes with a DIN rail for holding the circuit breakers. The insulating board on the back swings out so I can mount my components to it. I mounted two cheap Chinese charge controllers. These are 12 volt charge controllers. They turn the DC off the solar panels into something the batteries can use. This charge controller fried as soon as it was a month out of warranty. These charge controllers say they're rated to 60 amps. Unfortunately, they're only rated to 1400 watts in total power. This means I'd need 4 of them in total. If I buy a quality product, I can get a 5-year warranty. I finally opted for an Outback charge controller. I got the biggest one they made, and this is an 80 amp controller with a fan. Here it is with its covers off. It has a fan mounted on the top. This is where the cables attach. There are really only 5 connections. There's the connection for the mate, which is an RJ45, and that's their remote control that monitors what's going on. Then there's PV plus and PV minus, and this is the plus and minus from the solar panels. Then you have battery minus, battery plus, which is the minus and the plus from the batteries. It's really very simple. I removed the Chinese controller and I fitted the Outback. In this photo, I've got 4 panels wired up. Each of the panels can produce 5 amps 50 volts. Now after this has been turned into something for a 12 volt system, this is pumping in 40.7 amps. This is a lot more than I was expecting. I actually saw this go up to 44. I'd ordered the mate, which is fundamentally just a remote control. It connects with an RJ45 cable and allows you to monitor what's going on and to alter any parameters that you're allowed. The Outback has MMPT, which is maximum power point tracking. This means it gets a more efficient charge. In the process of assembling this solar panel system, I've received some conflicting advice from different solar experts. I was very disappointed when I discovered that my 80 amp charge controller can't actually connect all my panels to the 12 volt battery system. It's more than capable if I make the battery system 24, 36 or 48, but I wasn't expecting this, and my inverter's a 12 volt inverter. After a lot of deliberation, I've decided to change the battery arrangements to 48, and I'm going to buy the better quality inverter with a 5-year warranty as well. This is the inverter with its panels off. There's a positive and a negative which go to the positive and negative terminals of the battery, and a big earthed cable. There's AC out, which is the 240 out that the inverter makes, and then there's AC in, so that you can connect a generator up to back charge the batteries. This is what the batteries looked after I rewired them. I've got 8 6-volt batteries wired positive to negative, all the way through until it makes a 48 volt battery. I put my watering system on. This is actually only covering 6 of the batteries, and I had to add 2 extra batteries to make it up to a 48. I've been told it's unwise to add new batteries to old battery banks. However, my banks are only 6 months old, and I think I'm going to get away with it. With the charge controller operational, the heat that's being generated in its location means the fan's coming on. This has a downside. It's mounted to the wall of the shipping container, and it's acting like a loudspeaker, which makes the noise much louder inside. I'm going to have to rethink something. There's been a positive upside to changing the inverter from 12 volts to the more expensive 48 volt Outback. The cheaper inverter would consume current whether you had a load on it or not, and it was using quite a lot of current. The better quality inverter from Outback senses whether anything is on or not, and it goes to sleep when it's not needed. In real terms, the biggest consumer is the fridge. So when the fridge is at temperature, the motor shuts down and electricity isn't needed. Now the Outback's going to sleep. When the fridge warms up and the motor kicks in, it comes back online and supplies the power, and this means that the inverter's only running when the fridge is actually needing it. As a consequence, we're using a lot less power. The inverter's being put in a weatherproof box, so now I'm going to have to add the circuit breakers and the safety devices that are going to go in with it. I laid out the components and mounted them on an old board. So starting on the right, we've got the battery positive and negative and going through the knife switch, which has got fuses. Then a positive and negative going through a DC breaker. There's outputs to the inverter and the charge controller, and there's earth lines. The two breakers at the back are for the AC. There's the generator input to the inverter, and there's the AC coming out of the inverter, which will feed the containers. So here it is wired up. The inverter's on the left, the safety circuit breakers are in the centre, and I've moved the charge controller from off the wall of the shipping container into the box. Rubber anti-vibration mounts were never going to cut it. On a sunny day, the batteries will be fully charged by 11 in the morning. On an overcast or rainy day, they'll usually be full by the end of the day. Would you like to listen to the best sound in the whole world? If you're enjoying these videos, you can see the entire project from start to where we are now at www.containerhouse.wordpress.com.